This website uses Three.js to create a visualization of the Collatz conjecture. A link to the detailed explanation of the Collatz conjecture is in the description. When a Collatz conjecture is represented in a 2D graphic, it will look something like the image shown here, where each term represents either an odd or an even number in the sequence. Here I'll show you how to use the website. So start off by putting in how much you want to turn right with odd numbers, and then you'll put in how much you want it to write with even numbers, then what number you want to start at, and then what number you want to end at. And it will draw that many lines with the turns in them. So you can see here, we can zoom out, then we can see all of the different lines and where they end. So the y-axis represents how high the values will go and how many times the sequence will run before it stops and reaches 1. And then let's do a few more numbers. So this time we'll go 10 and 15 again, and then we'll start at 1, and then we will go up to 10,000, 20,000, which is usually the max that I like to run, because it'll take a minute to load, but then once you go into there, it will have very good performance, and it will not be very much slower than the other simulation with only 1,000 lines. And I'm able to get this performance using instancing, which will cause an initial longer load time, but then once it loads, it performs about the same. So now this time, I'll put -10, and then 15, and we'll start at, let's go 1, and then we will end at 50,000. So it can take more, but you usually will not want to go that high on lower end computers. Take a sec to load. Second now, and there we go. As you can see, once I load all of the lines, it can run it at about the same performance as 1,000 and 50,000 lines. And even if I go inside the swirl, or whatever you want to call it, it will still perform about the same. And then after this, I'll show you a few more patterns. So you can also enter any random values. So let's go -33 and then go 66 for the even numbers. And we'll start with 1 and then 1,000. And let's run it. It will create an interesting pattern, but you can get a ton of different results with any random set of numbers. So then let's go this time. We'll go -5 and 75. So I have not tried out many combinations yet, so let me know in the comments if you find any cool combinations. So we'll go 1 and 10,000, and then this is the result. Okay, it looks very similar to the last one. Thank you for watching the video today, and if you want to try out the simulation for yourself, you can go to carteros.dev/collatz3d, or if you want to check out any of the other projects I have, you can go to carteros.dev, and that'll take you to the main page where I have all my projects, including Three.js and Python programs.